Okay, so now we are going to solve problem 35. So I'm going to mark here problem 35 of chapter 2 of Halliday, and it's the 9th edition. So in this problem 35, the idea is kind of similar to the problem 34, but now the situation has inverted. In which sense? What we have is again one car, which we will be calling it the red car, moving to the right, okay? And we have another car, I'm going to call it the blue car, moving to the left, okay? And there will be a point where they meet. Now, what do they give us? They say that this blue car, the blue car is initially at this position, this initial position here, which is 270 meters. Okay. And the red car is initially in this position here, which now they don't call it 0. They say that this initial position is minus 35 meters. Okay. And what else do we have? They give us a plot that illustrates the motion of these two cars. Yeah. So they gave a plot for the position. Let's make this plot here for the position versus time in seconds, and position in meters for these two cars. For the red, as they told us, it starts at a position that is negative, right? So it starts somewhere here, and you can look by the plot. That is a curved plot, no? So the red car begins at rest, but it has an acceleration. We can see it from this graph. And they are asking the question of this problem is exactly that. What is the acceleration magnitude of this red car? Okay, so the question of this problem is exactly that. What is the acceleration from this red car? So the red car has an acceleration. Now, if you look at the graph, you will see that for the blue car, which starts here somewhere with 270, we get a straight line. Okay, so for this blue car, we know that there is no acceleration, right? So for the blue car, there is no acceleration. The velocity is constant. And they tell us what is the velocity of this blue car. So I'm going to write here, this velocity is constant, as we said, and they say that is 20 meters per second. Okay, now you have to look at the graph because there is another important piece of information, which is this point here where they meet. If you look at the graph, you will see that this is 12 seconds. Okay, so let's just mark. This was the initial position for the blue car. So this is the 270. This was the initial position for the red car, which was at minus 35. We know that they meet at 12 seconds. We know that this blue car is moving at constant speed, 20 meters per second. And the question of this problem is, what is this acceleration of the red car? Okay, and they are just asking for the magnitude of this acceleration. Okay, so where do these cars meet? Well, when their position becomes the same, when the position of the red becomes equal to the position of the blue. Okay, what is the equation for the red? Well, the red has an acceleration. So I have the initial position of the red, the initial velocity of the red multiplied by time, acceleration divided by 2 t squared. This is the equation for the red car. What is the equation for the blue car? Well, that's the easy one because there is no acceleration. So it's the initial position for the blue plus the velocity of the blue time. And I should not put dot here because it never changed. So I'm just going to put V. Okay, so this is the equation for the blue. When the position of the red and the position of the blue becomes equal, that's when they meet. Let's see what we know, what we can put here in these equations. What is the initial position of the red? They told us that it's minus 35, so I'm going to put this here. What is the initial velocity for the red? They said that the car starts at rest, begins at rest. So this initial position for the velocity for the red is 0. Okay, so I don't need to write anything. What is the acceleration? Well, that we don't know. That's what we are trying to find. Divided by 2. At which time do they meet? That's what the information that we got from the graph at 12 seconds. So I'm going to put here 12 squared, okay? Equals to what? The initial position of the blue. What is that? 270. Okay, so let's put 270 here. What is the velocity of the blue? They said is 20. Now careful here because the blue car is moving to the left. So let's put the direction here, minus 20, right? And what is the time? 12. So now everything is numbered except for what we want to find, which is this acceleration. So you should be able to find it now, okay? So this is the solution of this problem. So you see that you had to read carefully all the pieces of information from the text, but you also had to look at the graph to get that information that they meet at 12 seconds.